All right, so for question number 11 right here, it says that the image of a -3 and -5 under a translation is a prime, which is 6 and -1. Find the image of b 3 -2 under the same translation. So basically, we are looking for the translation of b, which is the b prime. So how are we going to go about this? So let's make it simpler. So what you are going to do if the question looks the same as like this, you're going to do is to just subtract the a image into the translation. So I'm gonna say 6 minus -3, okay, and minus 5 right here. So if you're going to subtract, this is 6 minus -3, so negative negative becomes positive, this becomes 9, 6 plus 3 basically. Okay, so negative negative is plus. Change the sign of the subtrahend and proceed to addition. That's what the rule for subtraction. And the same goes with -1 minus -5. So we have here 4. All right, so we have 9 and 4 as the difference, and then we'll take this to our next image and we're just going to add it to the points. So we have here 3 plus 9 will become 12, and -2 plus sorry, this is not 3, this is 4. Sorry for the mistake, let me erase it. This is 4 right here. Okay, so -2 plus 4 will be equal to 2. So your b prime will be 12 and 2. Okay, so minus first and then add it here. Okay, so this is how the flow will go. And then for number 12, we have here explain why triangle ABC prime with vertices A prime, -1, -2, B prime, 0, 0, and C prime, -6 and 0 is not a translation image of triangle ABC with vertices as given this way. Okay, so our cue or our clue or our keyword here is not a translation of an image. So we know that the figure is a translation of another image when they have the same translation vector. Okay, but then in this case, it says it's not a translation vector, so we can therefore say that the translation vectors are not the same. Okay, are not the same. So this is basically the answer for this question number 12. And for number 13, determine whether triangle P prime, Q prime, R prime is a translation image of triangle PQR and explain. As we all know, look at the sizes of the triangles. They are they are different in size. Okay, so this example tells us that the image is not a translation. All right, so P prime, Q prime, and R prime is not a translation of triangle PQR because, as we can see, the sizes are not the same. Okay, so this is the answer for this question 13. Now let's move on to the next example or to the next topic, which is using the third angle theorem and the properties of triangle congruence to solve problems and to prove relationship in geometric figure. So let us look at the diagram triangle ABC. So this is triangle ABC right here, and we have here triangle FDE. All right, so for number 6, you are asked to find the value of x. The answer is 36, but how did you get this? This is what we need to find out. And for number 7, find the value of y, which is equal to 48. So let's try to look for the answer for the questions that needs answer. So as we can see, angle C here corresponds to angle E. Okay, so if angle C is 108 degrees, this should also be equal to 108 degrees. And B corresponds to angle D. So if angle B is 48, that means y degrees here is equal to 48 degrees. All right. Now, we know also that angle A corresponds to angle F. Okay. And they are equal. So we have here angle F given as 2x minus y. So this is where we will get the value of x. So how are we going to do that? In this example, we need to find out first what is the value of f right here. So what we're going to do is to use the triangle angle sum. So we know that the sum or the sum of the measure of all the angles in a triangle is equal to 180 degrees. So I'm going to subtract this into 48 and then minus 108 degrees. So I'll get here 24 degrees. That means angle F is equal to 24 degrees, and this must be also 24 degrees. Okay, now we're going to look for the value of x right here. So how are we going to do that? I'm going to say 2x minus y is equal to 24. So because this is already known as 24. And then we already know that the y is equal to 48. So just substitute the value. Have here 48 equal to 24. Okay. Now, by addition property of equality, let's add both sides with 48. So this becomes 0, and I have left with 2x right here. So 24 plus 48 is 12, 31, 72. And by division property, we have to divide both sides by 2. So your x 72 divided by 2 is equal to 36. So this is where we got the answer 36. And for question 7, find the value of y. Is obviously written here, y is equal to 48. So the answer would be 48 for this. Now let's try to look at this example. So we are dealing with the polygons. So in the diagram, polygon A, B, C, and D is congruent to polygon P, Q, R, S. Understand? So it means that A corresponds to P, and then B corresponds to Q. So where's my B? B corresponds to Q. All right. And then C corresponds to R. So R is somewhere here. 1, 2, 3. And then we have D corresponds to S. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now we are asked to find the value of x. So the answer is 48. How are we going to get 48 here? This is what we are going to do. So as we all know, 2x, A corresponds to P. And so they are congruent. So I can write here 2x plus 4 is equal to 100 degrees. Okay. Now, if I'm going to solve for x, I'm going to use the subtraction property of equality. So I'm going to subtract both sides by 4. So I have left with 2x here, and 100 minus 4 is equal to 96 degrees. And by division method, okay, division property, we can cancel 2 here, and x would be 96 divided by 2 is equal to 48 degrees. So this is how we get 48 as an answer. Now, we are going to look for the value of y. So, according to this, the answer will be 5. Where will I get this? So, we know that this side corresponds to this side. Okay? So, we have this side is measured 3y minus 3. and that is equal to 12. Okay, so by addition property, I'm going to do this way. Have here 3y, this goes 0, and this is 12 plus 3 is 15. And divide both sides by 3 by division property, and our y is equal to 5. Okay, so this is the same answer as this. So this is all about this problem. Now let's move on to the next, the same problem. In the diagram, triangle ABC, so this is your triangle ABC, is congruent to triangle DEF. Okay, so let's try to look at the corresponding sides. So A here corresponds to D. So I can just take a symbol right here. A corresponds to D. B corresponds to E. So my B corresponds to E. And my C corresponds to F. So C, 1, 2, 3, and this 1, 2, and 3. And as you can see right here, we're looking for the value of x, which the answer is 27.8. So we know that this side is equal to this side, and this side is corresponds to this side. So the side AC corresponds to side BF, and side BC corresponds to EF. Alright, so we are looking for x, and this is where we are gonna get it. But do we know the y first? Alright, so we need to solve for y in this case. So if D corresponds to A, it means that 2y minus 5, we can say 2y minus 5 is equal to 65 degrees. Okay, so by addition property, I'm gonna add both sides by 5. I have here 2y, this becomes 0, and this becomes 70. So by division property of equality, we'll have here y is equal to 35. So that's why our y here is 35 degrees. Now, we know that y is 35. So in this case, I have to find the value of x by writing 2x plus your y is equal to 35. And this is equal to, so as we all know, this side corresponds to this side. So this is 90.6, okay? And we will be using the subtraction property of equality. So I'm going to subtract both sides by 35. So I have here 2x, 90 minus 90.6 minus 35. So how am I going to get this? 90.6 minus 35 is equal to 55.6. Okay, so this is 55.6, and by division property, divide both sides by 2. So your x here would be equal to 27.8. So